Welcome back, friends. In this lecture, we will discuss about phases of database design. There are two phases in the database design. One is DBMS independent phase. Another one is DBMS specific phase. So the DBMS independent phase consists functional analysis, requirement collections and analysis, and conceptual design. The output of the phase 1, that is DBMS independent, will be given to the DBMS specific as an input. DBMS specific contains three components. One is application program design, another one is transaction implementation, another one is physical design, and the intermediate component of both the phases are logical design, that is data model mapping. So when we are seeing the skeleton of the phases of database design, the first component is mini world. Mini world is the real world environment. So where we are going to get the data. So the data sets can be collected from the mini world, that is real world environment. So the requirement collections and analysis collects the data type or data sets. So what are all the data required? So it will be collected from the mini world, and the data will be sent to the conceptual design. So before going to the conceptual design, the collected data set will be sent to the functional analysis, so which have to satisfy the functional requirements. So after that, it will be again after completing the functional requirements, it will be sent to the physical design, which is enabled in the DBMS specific phase. So the next thing is, after performing the functional analysis, we will start performing the conceptual design. So after completing the conceptual design, the logical design will be taking place in between the database management system independent and database management system specific phase. After performing the logical design, which will create the data model mapping. So after mapping both the phases, so it will send to the application program design, and finally it will be sending to the transaction implementation. This transaction implementation will receive input from application program design as well as from physical design. So physical design will produce the internal schema, which is used to store data in the DBMS, that is in the database approach. So finally, after completion of the transaction implementation, it will be going to the application programs. So this is what the phases of database design. The next thing is ER notations, ER model notations. So ER model is defined as entity relationship model. So we already discussed what is meant by entity relationship model in the previous lecture. So this entity relational model will be having various components. So each component will be specify each shape. So you can see here the rectangle symbol will be used to represent an entity. The two rectangle symbols will be used to represent the weak entity, and diamond symbol will be used to represent the relationship between the entity or any other components, and double diamond will be used to mention the identifying the relationship. So for example, if we are having 4 or 5 entity in our entity ER diagram, so in order to identify the relationship among the entities, we will be using this double diamond shape. The next thing is attribute. Attribute will be mentioned with oval, and key attribute will be mentioned with a line inside the oval, and multi-valued attribute will be mentioned with the help of the double oval. So we will see the definition of the entity, weak entity, relationship, attribute, key attribute key attributes are already discussed in the previous classes. We will discuss about multi-valued attribute in the coming lectures. So composite attribute means, so 2 or 3 ovals will be interconnected. So in order to define the composite attribute, so derived attribute means a dotted line oval, and in order to mention the participation of entity in a relationship, we will be using this particular shape, a diamond which is connected with entity E1 and E2, and E2 will be having double line. Okay, the interconnection will be having double line. It specifies as total participation of E2 in R, and coordinality ratio means it specifies about the number of entities, or how the number of entities are related to some other entity. Okay, so it speaks about the size of the entity. Okay, the next thing is the structural constraint. This will inform about the maximum and minimum participation of entity in R. R means our relation. So these are some of the basic and important ER model notations. In the next lecture, we will discuss about more briefly about the ER model notations. So the references are from Elmosry and Naviti, Fundamentals of Database System, 7th edition, Pearson Education. Thank you.